Okay, I thought I'd do one more follow-up question as well, because I know some people find limiting reactant problems kind of difficult, and you might need a little bit of help with those. So I thought working through this example might be a good idea. So this is a stoichiometry problem. It says determine the mass of hydrogen gas produced if 75 grams of zinc metal is dropped into 200.5 mils of 0.450 molar hydrochloric acid. So in this case, when I look at this reaction, right, I've got zinc and hydrochloric acid produces hydrogen and zinc chloride. Now, this balances as a 1:2 ratio. So from my stoichiometry perspective, or think of our 4 steps that we have, there's my balanced chemical equation. Now, the next step would have us convert to moles, and then we'd be looking at a mole ratio, right? That's sort of the steps that we would work through. But the difference here with this problem versus the ones you've seen already in the other video that I did is that this is a limiting reactant. We're giving you information about both reactants. So in that case, we need to figure out which one actually limits the reaction. So we've got a mass of 75 grams of zinc. The molar mass for zinc is 65.41 grams per mole. And we need to figure out moles of zinc, right? Then we need to figure that out. The other information we have, the HCl, we've got a volume of solution of 200.5 mils, and we have a concentration of 0.450, that's a 4, molar. Okay, so that's my concentration. So we have enough information, we can find moles of both reactants. Then we need to look at figuring out which one's going to run out first. So once we can identify what's limiting, then we can use that substance to figure out how much hydrogen is made. And our goal ultimately is to figure out that mass of hydrogen, right? That's what the question's asking for. And we know to do that, we're going to need molar mass, which is 2.02 grams per mole. And we're going to need to find the moles using our mole ratio, right? So we've got a little bit of work ahead of us here. So let's start by converting to moles. So I'm going to sort of work this one piece at a time. So zinc, I'm going to start with the zinc. I'm going to convert to moles, right? I'm going to do my CTM, convert to moles, and figure out what that is. So I've got moles of zinc, so N equals M divided by capital M. So 75 grams divided by 65.41 grams per mole. And that is going to equal 1.1466137 moles, right? So that's our moles of zinc. The other moles I want to find are my HCl. So HCl, we're going to convert to moles so we can find it. So moles equals C times V, which we've got 0.450 moles per liter. And we're going to multiply that by 0.2005 liters. Remember, we need in our concentration calculation, we always need our volume to be liters. So because they gave it to us in mils, I've converted it to liters for my calculation. And once I do the math there, I'm going to end up with 0.0902225 moles HCl. So there's how many moles I've got of each substance. And in this calculation with the zinc, if we use it any forward into any other questions or any other parts of this solution, we're going to have 2 significant digits. If we use HCl, based on the info that we have, we're going to end up carrying 3 significant digits. So that's important just to keep track of as we're going through this. Now, I'm going to just sort of scroll on my solution, give myself a bit more space here. And if we look at the next part deals with our mole ratio, right? Now, there's a few ways to tackle this when you're dealing with a limiting reactant question. You could compare moles of the HCl and to figure out how much zinc you would need. You could figure out moles of zinc, how many moles of hydrochloric acid would you need to use up all the zinc. Or you can look at solving each of these things, if all the zinc was used up because it was limiting, how much hydrogen would we make? If all the HCl was used up, how much hydrogen would we make? And whichever makes the lowest amount of hydrogen, that's the one that's going to be limiting. So I'm going to approach it this way. I'm going to do two sort of steps here. So if all HCl reacts, right? So if we think that HCl is limiting, we can do our mole ratio, HCl to H2, which is a 2-to-1 ratio. So when I find moles then, I've got 0.090225 moles HCl. And I'm going to multiply that by, from my balanced equation, following my ratio, it's 2 moles HCl to 1 mole H2. And I'm going to end up with 0.0451125 moles of H2, right? So if HCl was limiting and we use all the HCl up, that's how much H2 we would get, right? And thinking significant digits for later, we've got 3 significant digits. Now let's consider what if zinc is limiting? So if all zinc reacts, now let's compare zinc to hydrogen, and it's a 1-to-1 ratio, right? So we know our 1.1466137 moles zinc times, and I know this is a nice 1-to-1 ratio, so it's pretty straightforward here. But we can figure this out and we will get 1.1466137 moles H2. Now, if we compare this, so if all the HCl reacts, we're going to get 0.0451 moles of H2. If all zinc reacts, so if zinc was limiting, we would get 1.14 moles of H2. So if we're trying to identify what's limiting, it's always going to produce the lowest amount, right? If it's limiting, it's going to run out first. So if all the HCl reacts, we can only make this much H2. There is no way we can possibly make this much H2, right? So this tells me something. This being lowest tells me that HCl is limiting. All right, so I'm going to make a statement here. Since HCl creates less, since HCl creates less H2, the HCl is limiting, and 0.04511125 moles H2 forms. Right, so now we're done our mole ratio step. We identified what was limiting. It's the HCl because it ends up creating less H2, and we know how many moles of H2 get produced. So the last step then, when we're going to solve this problem, is to find that mass, right? We want to find that mass. So we're going to get to the fourth part of this problem, which is find mass H2. So mass is just moles times molar mass. Our moles was 0.04511125 moles. And our molar mass was 2.02 grams per mole for hydrogen. And when we calculate that, we're going to get 0.0911275 grams, right? But thinking about our calculation and what we've done here, we were carrying 3 significant digits from the HCl measurements, right? So 3 significant digits came for moles of HCl. That's how many should be in our moles of H2. So we've got 3 significant digits here. We've got 3 significant digits here. My answer has to have 3 significant digits. So therefore, the mass of H2 produced is 0.0911 grams, right? And that's how we can solve a limiting reactant type problem when we're dealing with stoichiometry involving a concentration. So again, just to recap our steps, we did our balanced chemical equation, And then we found how many moles of each of the reactants we had because we were given information about both. Because both reactants are present and we know quantities of each, we had to figure out what was limiting, so we used our mole ratio to figure out which produced less H2, right? The thing that produces less of our product, that's got to be what limits the reaction. So we identified the amount of H2 produced in moles, and then we've converted that to mass using the molar mass calculation. And we've got 0.0911 grams. So this is another example for you to throw in your repertoire of stoichiometry with concentration. Hope you enjoyed it. Keep practicing.